All right, so this is for the last test of the second quarter. That's going to be on January 24th. Extra help will be on Wednesday, the 22nd. And then your review sheet, obviously, is due the day of the test. So for numbers 1 and 2, it asked you to find the inverse of those functions. So your rules for inverse are to switch the x and y values. So now this is x equals the square root of 3y plus 6. And then to solve this, to get rid of a square root, you square both sides. So now it's x squared equals 3y plus 6. X squared minus 6 equals 3y, and then you divide by 3. So you could write this multiple ways. You could write it just like this. I'm going to make my final answer the inverse notation, so -1, equals, I'm going to make this x squared over 3 minus 2. But if you wanted to write x squared minus 6 all over 3, that's still the same thing. For number 2, here when I switch the x and the y value, I get x equals 4 raised to the power of y. Now the problem here is that how do you bring down that exponent? To bring down exponents, we need to use logarithms. So I'm going to say that y, right, to go back and forth between a log and an exponent, the exponent comes out equals log. The base of the log is the base of the exponent, so log base 4 of x. And that is my answer. Log base 4 of x. For numbers 3 and 4, we have two exponential equations, but it says that we cannot use any logarithms for these questions. So for number 3, I have 81 and 1 over 27 as my bases. They can both be rewritten using 3's. So 81 is 3 to the 4th power raised to the 3 minus x equals, and 27 is 3 to the 3rd power, but this is 1 over 27, so this is going to be 3 to the negative 3rd raised to the 2x plus 6. So now this equation that I'm going to solve, power to power you would multiply, so this is 12 minus 3x is equal to negative 6x minus 18. This would give me, if I add the 18, 30, and I add the 3x, so 30 equals negative 3x, x is equal to negative 10, I plug it back in, it does in fact work. Same deal with number 4. Between 4, 8, and 32, my common base is going to be a 2. So 4 is 2 squared raised to the x plus 7 times 8 is 2 to the 3rd raised to the 2x minus 1, and 32 is 2 to the 5th raised to the x plus 1. So now here, not only do you have a power to power rule, but whenever you're multiplying two terms, you add their exponents. So this equation is going to be 2x plus 14, 2x plus 14, because you distribute this, plus 6x minus 3 equals 5x plus 5. On the left side, this would give me 8x plus 11 equals 5x plus 5. If I subtract the 5x, I get 3x. If I subtract the 11, I get negative 6. So x is equal to negative 2 for number 4. Numbers 5 and 6 condense the expressions into a single logarithm. So there were 3 properties that we had learned about. The first one, whenever you are adding two terms, the two things that you're taking the log of can be multiplied to be put together, to be condensed. If you are subtracting, that turns into division. And then also any coefficients can be rewritten as exponents. And all of those rules, they go back and forth. So if you have two things being multiplied, they can be pulled apart with addition. So for example, with number 5 and 6, for this first one, I'm going to move my exponents, the coefficients, to become the exponent. So this is log of x to the 4th plus log of y to the 5th minus log of z squared. And then I have these two things are going to be multiplied because of this plus sign. And then you're going to divide by z squared. So your final answer to 5 is log x to the 4th, y to the 5th, divided by z to the 2nd. For number 6, you can do the same thing. So the 1/3 power is really the cube root, right? If you remember this rule, x to the 1/3, it's power over root. So power is 1 over root. So it's really just the cube root of x. So this is log cube root of x plus log cube root of y minus log of z to the third. That one's normal. So these two, when you put these together, because they're going to be multiplied, you can put them together inside of that cube root. Divided by, because of this minus sign, z to the third. So final answer is log cube root of xy over z to the third power. Number 7, you're going to use those properties to solve these log equations. So for number 7, we are going to put together, you're going to condense the logs. So you're going to put together the 5x and the 9 using division because they're being subtracted. So now you have log base 2 of 5x over 9 equals 2. And then from here, you're going to put this into exponent form. So you start at the base and you run the race. So 2, this is now really saying 2 to the second power equals 5x over 9. 2 to the second power, that's really 4, equals 5x over 9. You can cross multiply. 36 equals 5x. So x is equal to, you can either write that as 7.2 or you can write it as 36 over 5 if you want. 7.2 does work as your answer. Number 8, a little bit more challenging because here, when you go to multiply, because this is addition, you are multiplying x plus 3 times 2x minus 1, and you're going to have to double distribute for this. So for number 8, I'm going to do this off to the right. This is now the log base 2 of x plus 3 times 2x minus 1 equals 2. So I'm going to do the same thing, start at the base, and I'm going to go around. So 2 squared equals x plus 3 times 2x minus 1. So this would be 4 equals 2x squared, and then that would be plus 5x minus 3. So 0 equals, this is a quadratic, 2x squared plus 5x minus 7. You do the whole master product, or you can do quadratic formula, whatever you want. You end up getting x is equal to negative 7 over 2, and x is equal to 1. You have to plug these back in and check them. Remember, to change the base of a logarithm, you can press alpha and then window 5, and that lets you change the base. When you plug in and check negative 7 over 2, that does not work. However, 1 does. Okay? And then the last one, number 9. Here we have more division. So this would be log base 4 of x squared minus 5 divided by 4x plus 3 equals 1. So start at the base. So 4 to the first equals x squared minus 5 over 4x plus 3. We're going to cross multiply. 4 to the first is really just 4. So you get x squared minus 5 is equal to 16x plus 12, which is really the quadratic equation. X squared minus 16x minus 17 equals 0. You go through, you do master product, you would get x minus 17 times x plus 1, giving me x is equal to 17 and x is equal to negative 1. Plug both of those answers back in, you'll see that negative 1 will not work. Only answer to number 9 is x equals 17. For numbers 10 through 12, so these are your exponential equations, but here you cannot get common bases. So for these, you need to use logarithms. So first you would divide by 32. So now I have 3 raised to the 7x is equal to 4 over 32. which is 0.125. Once the base and the exponent are by themselves, you can take the log. And when you take the log, that exponent comes out front. So you have 7x log 3 is equal to the log of 0.125. You divide by the log of 3. 7x is equal to, you write out 5 decimals, negative 1.89278. Okay, you keep that full number in your calculator though. Divide by 7. We wanted it to be rounded to the nearest thousandth, I believe, which would give me negative 0.270 for number 10. Number 11. First, you are going to add over the 1074 and then divide by 1510. So first, after I add over the 1074, I'm at 2600 equals 5510 times 0.98 raised to the x. I divide by 5510. I write out 5 decimals. So now I have 0.47186 equals 0.98 raised to the x. Once the base and the exponent are alone, you can take the log of both sides. So now I have the log of 0.47186 equals x log 0.98. And then I divide by the log of 0.98. And that gives me x is equal to, so remember, keep that full number, the 0.4718 number, in your calculator. And you're dividing by the log of 0.98, which gives me a final answer, rounded to the nearest hundredth, of 37.176 for number 11. And last one of these is number 12. So first, you are going to subtract over the 5,300. So 12,600 minus the 5,300. So this is now 250, 1.115 raised to the x over 2 plus 1 equals, this is all an exponent, it doesn't look like it, but equals 7,300. And I'm going to divide that by the 250. So now I'm at this. I have 1.115 raised to the x over 2 plus 1 equals 29.2. I go to take the log of both sides. That entire exponent comes out front. So now I have x over 2 plus 1 log of 1.115 equals log of 29.2. I divide by the log of 1.115. So I get x over 2 plus 1 is equal to, again, 5 decimals at least, is equal to 30.99708. I subtract the 1, 29.99708, and then I cross multiply, and I get x is equal to 59.994, rounded to the nearest thousandth. Number 13, we have 13 to the end. They're all review questions. They're all old stuff. So for number 13, this is a circle linear system. So I'm going to rewrite this as y is equal to negative x minus 3. I'm going to take that negative x minus 3 and I'm going to plug it in for y right here. So I have x minus 1 squared plus negative x minus 3 plus 3 squared equals 13. So then this is x minus 1 times x minus 1 plus negative x minus 3 plus 3 is just negative x squared equals 13. So now I have x squared minus 2x plus 1 plus x squared and then minus 13, because you have to bring that over and set it equal to 0, equals 0. So now this equation is 2x squared minus 2x minus 12 equals 0. If you want to make it easier, you can divide everything by 2. X squared minus x minus 6 equals 0. You do master product, or you can do quadratic formula. Either way, you end up with x minus 3 times x plus 2, giving you the answers x is equal to 3 and x is equal to negative 2. That's not done though. This is a system, so I know that x is either 3 or negative 2. I have to still find those y values. And we have this equation here. Y is equal to negative x minus 3. Y is equal to negative x minus 3. That gives me negative 6. So one answer is 3 comma negative 6. The other one, y equals negative x minus 3. That gives me a negative 1. So my other point is negative 2 comma negative 1 for number 13. For number 14, algebraically determine whether the function is even, odd, or neither. So determine algebraically, you plug in negative x and then you clean it up. So we have 4 times negative x to the third minus 7 times negative x. So negative x to the third, a negative times a negative times a negative is still a negative. So you are stuck with changing that sign. So that's negative 4x to the third. And then negative 7 times negative x is positive 7x. So because we went from positive 4x to the third in the original to negative 4x to the third, and from negative 7x in the original to positive 7x, everything is the opposite, which means that this function is odd, which means that there is rotational symmetry of 180 degrees. If you turn this picture upside down, it'll look exactly the same. Number 15, determine the equation of the parabola. So the equation of a parabola, again, that formula is x minus h squared equals 4p y minus k. All right, so your focus is at 4, negative 7, so I'm going to draw it. Again, you just draw these. Makes it a lot easier on yourself. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7 is down here. And then y equals 3, 1, 2, 3. That line is right here. So if you count the distance, these two are 10 units away from each other, which means you have to go 5 in the middle of them to figure out the vertex. So if I go down 1, 2, 3, 4, 5, I would be at 4 comma negative 2 is my vertex. This would be concave down because, again, your parabola has to go to hug the focus. So 4, negative 2 is the vertex. You are going down. So P is negative. You are going down 5. So P is negative 5. So when you plug this into your equation, you get x minus 4 squared equals 4 times P is negative 20. Y minus k. So minus negative 2 is y plus 2 as your final answer. And the last question on here. So a company is producing a new line of weighted blankets. The cost for the production of the weighted blankets is C of x. X represents the number of weighted blankets produced in hundreds. And then the revenue is R of x. And x, again, is the number of blankets produced in hundreds. Write a polynomial P of x that represents the total profit generated by the blanket. So it doesn't say it should, but it is, you can assume in this case, just because I'm telling you right now, that in P of x, x is also in hundreds. So you don't have to worry about any of that conversion stuff. Okay? So to figure out if you have the cost for production and you have the revenue, the way that you figure out the profit is by subtracting the two of them. Your profit function is equal to the revenue, how much money you made, minus how much money you spent. So you're going to be subtracting these. So P of x is equal to the revenue is 2.75 x to the 4th minus 8.12 x squared minus, make sure you subtract all of c of x. So 3.87 x to the 3rd minus 2.59 x squared, and then plus 13.65, close the parenthesis. You distribute the negative to everything. So you are going to combine like terms. You have 2.75 x to the 4th minus 8.12 x squared plus 13.87x plus 12.04. I'm going to go on to the next line just because I don't have any room. Then you have minus 3.87x cubed plus 2.59x squared minus 13.65. So your final answer after you combine like terms, final answer to number 16, p of x is equal to 2.75 x to the 4th minus 3.87 x cubed minus 5.53 x squared. You're going to put all of this on the same line. I'm just running out of room on here because I'm trying to write big for you. Plus 13.87 x minus 1.61. Okay? So what that hundredths thing means is if you're looking for the profit, if you make 600 blankets, you would only plug in 6 because the x value is in hundredths. Okay? If you have any questions about that or anything else from the review sheet, come to Extra Help on Wednesday after school. Happy studying.